Okay, well, I'm not exactly sure what the point is of this question, but I guess the answer is 1,936 pi over 15. So we can just move on to the next one. Okay, so we want to do this integral. E is the region that lies above this standard right cone and between these two spheres. Okay, so let's think through this for a little bit. So this region is difficult for me to sketch in 3D, but I can try to sketch it like what a cross section would look like in the XY plane, or really what the projection of this region onto the XY, onto the, um, sorry, not the XY plane, say the ZX plane. So what is the projection of this shape onto the ZX plane? Well, the cone Z equals X squared plus Y squared is going to be something like this. Okay, and now the sphere is X squared plus Y squared equals 1. That one is going to look roughly like this. And then the sphere X squared plus Y squared equals 64. That's a sphere of radius 16. It's going to look something like that. Okay, now the region that we're interested in is going to be this region right here. Okay, it is a sphere above, it is the region above the cone, that's the red part, and in between these spheres. So this is kind of the region that we care about here. Okay, so now to think about what this looks like, just like spin this region about the z-axis, and that's what the shape is going to be like. So it's like a spherical annular region enclosed in the cone z is equal to x squared, the square root of x squared plus y squared. Okay, so let's try to figure out what the bounds for the integral are going to be. So let's do the r bounds, or sorry, we want to do this in spherical coordinates. So the r bounds, or the rho bounds. So no matter what phi is, in other words, no matter where you are kind of from here to here, no matter what theta is, in other words, no matter how much you've spun around the z-axis, rho is always going to go from the sphere of radius 1 to the sphere of radius 16. So rho is going to go from 1 to 16. Now phi, okay, now phi, what about phi? Well, let's see if I can get a different color here. So phi is, so we're going to start out here and go over here. Okay, so this is kind of the angle that tells us about phi. So when you're at this point right here on the z-axis, phi is equal to 0. When you're at this point right here on, or this point right here on the cone, or when you're really any point on the cone, then phi is equal to pi over 4. And remember, that's because this right cone is a right cone, it's a right angle cone. And so this means that um, the angle from the z-axis to the cone is pi over 4. Another way to see that using spherical coordinates is if you write this equation for the cone in spherical coordinates, this is rho cosine theta. That's the left-hand side. That's the left-hand side of z is equal to the square root of x squared plus y squared. Remember, in cylindrical coordinates, x squared plus y squared is rho squared sine squared phi. Or sorry, messing this up. This is cosine phi. So the left-hand side of this equation is rho cosine phi. That's z in spherical coordinates. Okay, now in spherical coordinates, x squared plus y squared is rho squared sine squared phi. So the right-hand side of the cone equation is just rho sine phi. Okay, so in other words, when you're on the cone, if you're a point that lies on the cone, then rho cosine phi is equal to rho sine phi, which just says cosine phi is equal to sine phi. In other words, phi has to be equal to pi over 4. Because remember, phi just goes from 0 to pi. And then theta is going to be, we want to spin this around the whole z-axis the whole way. So it's just going to be 0 to 2 pi. Now, if we had said something like we wanted it to lie in the first quadrant, then it would have been 0 to pi over 2. Or if we wanted it to lie in the y is equal to greater than or equal to 0 region, we would have said 0 to pi. But since we want just this whole region that is above the cone and between these spheres, its theta is going to go from 0 to 2 pi. Okay, and so now what does the integral become? Well, now we just fill in the information. Okay, and then so this is what we get when we fill in the integral. So remember, when we do spherical coordinates, we always write rho squared sine phi d rho d phi d theta, just like in polar it was r d theta. Okay, and then these are the bounds. Rho goes from 1 to 16, phi from 0 to pi over 4, and theta 0 to 2 pi. Okay, now this function, x squared plus y squared plus z squared, remember, that's just rho squared in spherical coordinates. So then when you take the square root, you get rho. Okay, and so now this is the integral to 2. Again, it might be tedious, but it is straightforward.